Hello everyone, this is Tony Merriman. I'm a meteorologist with the Weather Service here in Flagstaff, Arizona, and this is SKYWARN Storm Spotter Training. So first off, I want to talk a little bit about exactly who the National Weather Service is and who we represent. Our mission statement is to provide weather, water, and climate data, forecasts, and warnings for the protection of life and property and the enhancement of the national economy. We were established a long time ago by Ulysses S. Grant, way back in 1870 as the Weather Bureau, right after the Civil War. And so in terms of the bureaucracy, how it works, the Weather Service, we're here at the bottom, and our parent agency is NOAA, and above NOAA is the Department of Commerce, and then above the Department of Commerce is the President. So that's kind of how the bureaucracy looks for the National Weather Service out here in the field. And we're here providing weather services 24/7, 365 for the protection of life and property. The Weather Service is decentralized. We have national coverage 24/7, 365. There are 122 offices across the country. And the really cool thing about that is that each office provides localized weather forecasts and warnings to each local area. So if you look at Arizona, you can see that there's a weather office in Flagstaff. There's also a weather office in the Phoenix area, and there's one in the Tucson area as well. So your weather forecast for Flagstaff comes from meteorologists who live and work in Flagstaff, and similarly, your forecast for Phoenix comes from meteorologists who live in Phoenix, and the same goes for Tucson. So this is the same all over the United States. There are 122 offices across the United States. That's staffed 24/7, 365. So what is a SKYWARN Storm Spotter to begin with? The primary purpose of a spotter is to both observe and report severe weather within your local area. So we're not training storm chasers today, but we're training SKYWARN Storm Spotters whose responsibility is to observe and report severe weather within your local area. So if you're shopping or just doing your day-to-day activities, if you do observe severe weather, you don't have to be at your house to observe and report severe weather, but we don't want you out there chasing either. Safety is our #1 priority. So again, the purpose of a SKYWARN Storm Spotter is to observe and report severe weather to the National Weather Service. So why do we need spotters if we have all of this technology available? Our first issue is that we have radar limitations. Near the radar, the radar actually sees thunderstorms basically from all the way from the bottom to the top, but the farther away a storm is from the radar, so that's the thunderstorm to the right, the higher up the radar beam goes into the cloud and we can't see all the action underneath the radar beam. So what SKYWARN Storm Spotters do is help us get ground truth and get us a better idea of exactly how much hail a thunderstorm is producing or flash flooding or anything like that. So radar can only see so much based off of its just fundamental limitation that the beam height actually goes up the farther away it gets from the radar itself. So it can't really see the entire thunderstorm as well as, let's say, a SKYWARN Storm Spotter can, and we want to get reports of for ground truth information. Another reason spotters are important is that trained weather spotters add credibility to our severe thunderstorm warnings, flash flood warnings, and even tornado warnings as well. So regarding social science, if somebody hears that a trained weather spotter reports, let's say, large hail or 60-mile-an-hour wind gusts, people tend to believe that over, let's say, a radar-indicated thunderstorm as well. So trained weather spotters add credibility to our warnings that we produce during monsoon season. So this is how spotters help our operations, and this is just an example from 2018. And this is a large thunderstorm that went through the Holbrook area back on September 1st, 2018. Spotters tend to be mapped in our database, and whenever we're putting out severe thunderstorm warnings or tornado warnings, we also overlay the spotter information. So we'll have a name and a phone number, and that doesn't go beyond our local operations. And so in this case, let's say we see this line of thunderstorms approaching spotter X, And usually what we'll do is our warning meteorologist, our radar meteorologist, will give a phone call to spotter X, letting them know that they're expecting severe weather in the area, possibly large hail, and to be prepared for severe weather. As the radar advances, we see the storm approaching spotter X and hope that the spotter is taking proper shelter and is being safe from the storm. And then we see the storm moving right over the location where the spotter is located. And then once the storm passes and once it's safe, it is our hope that our spotter contacts Weather Service Flagstaff with hail, wind, or tornado report, and that way we can update the warning with the appropriate ground truth information. And so after about 15, 20 minutes after the storm passes and we don't hear from the spotter, we do call the spotter again just to see if they're safe and to check on them and to see if there's any report of large hail or if it's just heavy rain that fell. So that information is critical for Weather Service operations to update warnings with the latest and most up-to-date information to warn people that are possibly going to be affected by the storm down the road. All right, so real quickly, going over a few definitions. We're talking about monsoon season and storm spotting during monsoon season. So our most frequent warning that we put out during monsoon season is a flash flood warning. And our flash flood warning definition is that it's a rapid rise in water in a short period of time, and it's usually within 6 hours of the causative event. And that's usually heavy rain from monsoon thunderstorms. It can also be called, we can put out flash flood warnings if there is a dam break or something like that as well, because it's a rapid rise in water in a short period of time. So it doesn't always have to be caused by heavy rain, but usually during monsoon season we see it caused mainly by heavy rain in the area. So you can see on the image flash floods occurring over the road, and the truck is doing the right thing and stopping and it's turning around. And like we always say, turn around, don't drown. It's never worth driving into a flooded roadway. By definition, a severe thunderstorm, it produces winds that are either 58 miles an hour or greater, or hail that's 1 inch in diameter or larger. So a lot of these severe thunderstorms can produce both high winds and large hail, but oftentimes it'll produce one or the other. Either way, that is what's considered a severe thunderstorm. So whenever you hear a severe thunderstorm, think hail and or wind damage. So that's what we mean by a severe thunderstorm, is high winds or damaging hail. And then we also put out what are called tornado warnings. Now, we don't put these out quite a bit in the Southwest, but we still can get tornadoes in Arizona. And by definition, a tornado is a violently rotating column of air that's in contact with the ground. So on the picture on the left, you can see that the tornado condensation funnel is going all the way to the ground. So whenever we see spinning debris and the condensation all the way on the ground, that is considered a tornado. Now, a funnel cloud is a violently rotating column of air that's not in contact with the ground. And so you can see the image in the bottom left of a funnel cloud where it is spinning, there's a condensation funnel, and there's no evidence of swirling dust on the ground, and therefore that vortex is not touching the ground. So that is a funnel cloud. We need to know both occurrences because that funnel cloud can easily become a tornado in no time. So we rely heavily on our spotters to provide us with that information and to know the difference between a tornado and a funnel cloud. All right, transitioning to monsoon season. So we talked about the details of our flash flood warnings, of our severe thunderstorm warnings, and our tornado warnings. And so now we're going to look at the big picture of monsoon season and what causes all these thunderstorms in northern Arizona. So when we look at monsoon season, which by definition is June 15th through September 30th, again, that's just a definition, it's June 15th through September 30th. If we look at the average weather pattern during the month of June, we get dry westerly flow over Arizona. So that's why June is climatologically the driest month out of the year. It's when we get the dry westerly flow over Arizona. And you see the high pressure just to the south of Arizona over the Gulf of California and western Mexico. So that's a typical pattern over the southwest during the month of June. Now, if we look at the image on the right, we're looking at the month of July, and that moisture from the Gulf of California actually starts moving farther north into Arizona as that high pressure shifts into north central Texas. So flow around that high pressure draws in moisture from the Gulf of California north into Arizona during the month of July. So it opens the door to moist southerly flow, and we start seeing more monsoon season type thunderstorms during the month of July. And these are all just average weather patterns that we see during the monsoon season. So just to recap, the image on the left is a typical June dry pattern, and then that high pressure shifts farther north into Texas during the month of July, opening the door to Gulf of California moisture over Arizona, and that's when we'll typically start to see monsoon season thunderstorms. A little more detail. We're looking at thunderstorm ingredients, and meteorologists on a daily basis look at these ingredients to try to assess if there's going to be thunderstorms or not for any given day. And our first main ingredient that meteorologists look at is moisture. And again, just kind of reiterating what was on the last map, our primary source of moisture across Arizona during monsoon season is from the Gulf of California. Sometimes we can even get moisture coming from the Gulf of Mexico over the Sierra Madre and into eastern Arizona. And on very rare occasions, we can get moisture from North Texas and Oklahoma moving into the Four Corners region and eastern Arizona. But most of the time, our moisture source is from the Gulf of California. So our first ingredient is moisture. That's what we look for whenever we're looking at the potential for thunderstorms. The second ingredient that we look for regarding thunderstorms is a concept known as convective instability. So simply put, all we're looking for is warm air rising. So whenever we look at the atmosphere, we know that the atmosphere is a fluid. We also know that, let's say, a pot of water is a fluid that's in a pot. And so when we add heat to the bottom, we'll get what are called parcels of air that become buoyant. So we don't typically see that in the atmosphere because water vapor as a gas is invisible to the human eye. But whenever that buoyant parcel of air goes up into the atmosphere, it cools and condenses into a cloud that we can see. So with boiling water, we're adding heat to the bottom. You start seeing bubbles become agitated at the bottom of the pot, and then whenever they reach their convective temperature, you'll start seeing the bubbles rise to the top of the pot. So a similar concept where you're heating the bottom and you're getting buoyant parcels in a fluid, but that's just kind of conceptually what we're looking at whenever we look for convective instability. Simply put, just warm air rising. That's what we're looking for. The third ingredient that we're looking for is called lift, and in the Southwest, our typical lifting mechanism is orographic lifting, which means that the Mogollon Rim, the Bradshaw Mountains, the Chuska Mountains, Black Mesa area, those areas of orographics are forcing the air to go up. And so that's usually where we'll see our thunderstorm initiation. That's where thunderstorms will usually start, are in areas of higher elevation, and that's due to a thing called orographic lift. So we're looking at orographic lifting typically. We're looking at moisture and instability during monsoon season. Another lifting mechanism that we often see is something called an outflow boundary. So the image on the left, you have a large thunderstorm producing heavy rain and some lightning. And that heavy rain falling to the surface of the earth is creating cool air underneath the thunderstorm. And so the air surrounding that thunderstorm is warm and moist and actually probably very unstable as well. And so whenever that big thunderstorm produces the rain and cold air. That cold air pushes out, and in the image it pushes to the right, and it acts as a small cold front or a lifting mechanism for new thunderstorm development. So we're often on the lookout for outflow boundaries, especially during early monsoon season, as oftentimes these outflow boundaries can shift winds on, let's say, wildfires or any other kind of fire activity in northern Arizona. So it's really critical for our fire weather partners to know when these wind shifts are going to happen, and also when these outflow boundaries are going to possibly affect a certain area. So digging a little deeper into thunderstorms, so we have moisture, instability, and lift. And when all of that comes together, we start to see thunderstorms develop. And so there's three main phases of thunderstorms that we look for whenever we're looking at the sky. So as a SKYWARN storm spotter, you're looking out at the sky and you're using clues to try to assess if a thunderstorm is, growing in nature, or if it's possibly going to be producing hail or even a tornado, if anything like that. So the first phase of a thunderstorm that we're going to talk about, like we have moisture, instability, and lift coming together. The first phase is called the towering cumulus stage, and this is usually when we start to see that first billowing cloud going straight up. You have the updraft pushing all that warm, moist air up, and because those buoyant air parcels are cooling, it's condensing into a cloud that we can see. So whenever we get into this towering cumulus stage, that's usually when we'll see our first flash of lightning and see the thunderstorms start to develop. And if the conditions are right, it'll continue to grow and mature over the next 20 to 30 minutes. So the second stage of a thunderstorm that we look at is something called the mature stage. So if you look at the image on the right, you can see that it's a very mature updraft that we're looking at, and so all of that warm, moist, buoyant air is going up into the atmosphere, and as it's doing that, it's cooling and it's condensing into a cloud that we can see. A lot of these air parcels, as they go up and condense into clouds and water droplets, and because it's so cold, it can also convert into ice as well. And so whenever you have big water droplets in the cloud and ice, it'll start falling back to the surface of the earth on the left side of that image in a form called a downdraft. So we'll have rain and hail mixed together during the mature stage, where you're going to have much colder air falling to the surface of the earth, and encapsulated within it are raindrops and possibly even hailstones. So depending on the strength of the updraft, you can get large hailstones getting drawn back into the updraft, falling down the downdraft, and then getting drawn back into the updraft and downdraft. And so that cycle can continue depending on the strength of the updraft to produce large hail. So as long as the updraft, which is the concept shown on the right, is separated from the downdraft, which is the downdraft stage part of the thunderstorm on the left, as long as those two are separated, it can be a very mature, long-living thunderstorm for at least 30, 45 minutes and can produce heavy rain and large hail. So the last stage of a thunderstorm, it's called the dissipating stage, and this is usually when the downdraft undercuts the updraft. So there's no more warm, moist air feeding into the thunderstorm, and it's all just dissipating, and the cloud will have a feathered look to it and maybe even look a little like cotton candy. But this is the dissipating stage of a thunderstorm, and usually this is when it'll turn into more of a fair weather cumulus type cloud, if not just dissipate altogether. So we talked about the different stages of a thunderstorm. You had the beginning stage, a thunderstorm is born, towering cumulus. You have the mature stage when it's a very mature updraft and a very mature downdraft, and it's a long-lasting thunderstorm. And then you also have the dissipating stage, so that's kind of the end of the thunderstorm's life cycle. We're going to talk a little bit about thunderstorm types. These are not all the same. So some thunderstorms are weak and some are very strong. So what is the ingredient that we need to differentiate between what's going to be a weak thunderstorm or a strong thunderstorm? And it's a concept known as wind shear. So our single cells are typical monsoon season thunderstorms, or even some multi-cells, and that's the image on the left, that is due to weak wind shear. So the way to read this chart is that the wind direction, and that's where the wind is coming from, is annotated by the wind barbs, and the actual flags off of these barbs tell you just how strong the wind is. And so you can see the image on the left all the way up to 30,000 feet. This particular wind profile is weak and it's pretty disorganized. So all that moisture and instability and lift come together, an updraft forms, and then it just collapses on itself, and that's just your typical monsoon season single cell or even multi-cell thunderstorm that we see during the monsoon season. The image at the middle, it's showing a little better wind shear, so this is strong wind shear, and you can see that the wind profile is actually veering with height, so it's actually starting from the south at the bottom, becoming more southwest as you go higher up, and the wind speeds are actually increasing, so the winds are getting stronger as you go higher up in the atmosphere. And so what that does is it tilts the updraft, and it allows the updraft and the downdraft to remain separate for a long period of time. So if you have strong wind shear, then you'll have a long-lasting thunderstorm that can produce flash flooding or even some squall lines in the valley area as well. And these can produce haboobs and things like that, and dust storms. So the third type of wind shear is something called extreme wind shear, and you can see that not only are the winds veering with height, but they're also getting really strong the higher up you go. So not only is my updraft tilted, but it's also rotating. And so this environment is really conducive for something called supercell thunderstorms. So the whole updraft is rotating and everything is organized, and this can often produce funnel clouds, if not tornadoes, if you have a supercell thunderstorm. So we'll go through some examples, and going back to our single cell thunderstorms, these are the most common storm types in Arizona. Typically, there's a lifespan between 20 and 45 minutes, and if you see a cloud like the image on the left, those are a typical single cell thunderstorm. And then if you're looking at radar, which is the radar image on the right, you can just see disorganized storm clusters, and that's just a very typical monsoon season radar. You might get some rain, and you might get no rain. That's just the nature of monsoon thunderstorms. They're hit or miss. Looking at multi-cell clusters, this is the second most common storm type in Arizona, and this is when we can get some back building over the same area and possibly cause some flash flooding. So if you look at the image on the left, if I have a stationary boundary or a lifting mechanism in the same spot, and I have wind flowing parallel over that particular lifting mechanism, I can get persistent thunderstorms over the same area, and you can even see the different stages of a thunderstorm as it's moving across the same boundary. So you'll have your towering cumulus phase, a mature phase with heavy rain on the downdraft side, and then a dissipating stage downwind. And so this back building of these multi-cell clusters are often the cause for flash flooding. And so the radar image on the right is showing taken a few years back over the museum fire. So this is the museum fire scar over here, and you can see thunderstorms building up just north of Flagstaff and persisting over the same area for a few hours before finally moving off to the southwest. So this is often what we see during our flash flood days during monsoon season, are multi-cell clusters that backbuild over the same area and cause flash flooding. A third type of thunderstorm that we typically see during monsoon season are squall lines, and these typically roll out of the mountains and into the central and southern deserts of Arizona. These often produce straight line winds and wind damage and produce the ever-famous haboobs across Phoenix and the valley metro areas. So the image on the right, this video, is showing how a squall line typically forms off the mountains and then pushes across the central and southern valleys and off and down into Mexico as well. So this is another thunderstorm type, squall lines. They're pretty rare, but they often do happen, especially across the central and southern valleys of Arizona. A fourth type are these supercells. These are individual cells with intense and persistent updrafts. Usually we'll see these maybe in the late summer and early fall in Arizona, but they're pretty rare. And so the video on the left is showing what's called a wall cloud from a supercell that is rotating, and you can see the striations of the updraft, and it's organizing and rotating. But luckily from this image in this video, a funnel cloud or a tornado did not decide to develop. So the graphic on the right shows what a typical supercell structure is, and the video showed the wall cloud developing, but what you'll notice is just the sheer size of a supercell, and that wasn't really captured in the video because it's so large that you can't really see an individual supercell in just one still image. And so these supercells, again, you have inflow into the updraft. The whole thing is rotating. The updraft is so strong that it's actually penetrating the stratosphere and producing an overshooting top. And then you'll have, on the downdraft side, rain or hail. And possibly on the updraft side, you can get a wall cloud that eventually develops into a tornado. So these are more typical in the Midwest and the Southern Plains during the spring and early summer months. But we can see these in Arizona typically during the September and October months as well. All right, so we did a lot of thunderstorm exploration, and here's some statistics, some weather safety statistics, and hopefully these make sense. So all the way through 2021, the #1 weather-related killer in the United States, these are weather fatalities across the entire United States, the #1 weather-related killer was heat, and in 2021, at least 375 folks perished due to the heat, and that's that big red bar in the middle. The #2 weather-related fatalities were floods. #3 was rip currents, and #4 was actually the cold, and #5 were tornadoes. So you can see that our major weather-related fatalities are very typical Arizona hazards of heat and flooding. So that just, hopefully this drives the point home that you should always take heat seriously, take flooding seriously, and of course take tornadoes seriously as well. So for floods, weather safety, water always flows faster and is deeper and hides way more damage than what you'd think. We always say to turn around, don't drown. You want to be safe when it comes to flooding. And again, 2021, the U.S. flood fatalities, the activity of the victims, over half of the people who perished in floods were driving. So about 55% of folks were driving and they drowned into a flooded roadway. About 29% were at home, so they were victims of flooding into their homes. And the others were walking, boating, working, or some folks might have even fallen in to flooded roadways. For lightning, lightning is hotter than the surface of the sun. It can reach temperatures of 50,000 degrees Fahrenheit. And so, again, when thunder roars, go indoors. We always want folks to be safe from lightning. Lightning can be a killer. And so when you hear thunder, you're close enough to be struck by lightning. For tornadoes, the best place to be safe from a tornado is an interior bathroom on the lowest floor, and that's the safest place than any other room. And so your safe rooms are going to be your interior rooms, and the way you take shelter is to cover your two most important organs, your brain and your heart. So if you look at the image in the lower right, you want to squat against a wall and cover your head and try to protect yourself from any tornado damage that could occur. All right, so we talked about thunderstorms and weather safety. Now we're going to talk about wireless emergency alerts. How do you get these warnings? you already have them on your smartphone. As long as your smartphone was manufactured after 2012, you will receive these warnings, and they're automatically sent to your cell phone, and it's based off your location. And most of your smartphones are already automatically set up to receive. And so you can configure settings on some of the smartphones. For an iPhone, you just want to check your notifications and your settings, and then you can see the government alerts, and if your Amber Alert is set up, emergency alerts or public safety alerts are toggled on. We strongly recommend you toggle all of those on. Now, if you have an Android device, again, it's under your settings, your apps and notifications, and you look at your emergency alerts, and hopefully you keep your Amber Alerts toggled on, extreme, severe, and public safety messages toggled on. And so these will keep you safe from severe weather. Whenever we put out flash flood warnings, you'll receive them through what's called the wireless emergency alert system. Same thing with tornado warnings and destructive severe thunderstorm warnings as well. All right, so we talked about all kinds of things regarding severe weather. And again, this is SKYWARN Storm Spotter training, so after all of that, I just kind of want to wrap this up and talk a little bit about what exactly do we want our storm spotters to report. And so this slide shows you that we want you to report flooding, any kind of flooded roadways. Whenever it's safe, just let us know what particular road you're looking at is flooding and how deep the water is if you can judge by just looking at it. We definitely do not want you entering any flooded roadways to get the depth. So if you can estimate it, that's wonderful. We'll take it. We also want you to report high winds, so any kind of severe winds or wind damage from thunderstorms. That way we can properly assess the strength of a thunderstorm. So 60-mile-an-hour winds or greater, we definitely need to know when you see that in your local area. If you encounter any blowing dust, again, so that's more of a Central and Southern Valley issue, but we can get blowing dust primarily in the Winslow area along I-40. And so if you ever encounter blowing dust, as ADOT says, pull aside, stay alive, and we want you to be safe and not be a victim of any kind of collisions during a blowing dust event. So once it's safe, please contact the Weather Service and report blowing dust and just how bad the visibility is and where you are. That's after you're safe and pulled off to the side. We also want you to report hail of any size and let us know just how much hail it is and how large the hail is. We measure hail by the diameter of the hailstone. So if you can find one of the largest hailstones in a field and report that measurement to us, that's exactly what we're looking for. Now we know it'll probably be a lot of, let's say, half-inch wide hail, but there could be one-inch hail in there. Let us know that. Both that information is great for our warning operations to have. Definitely, we want you to report any tornadoes that you see, and especially if there's a condensation funnel hitting the ground. But again, if there's swirling dust touching the ground, we need to know that as well, because that means the vortex is touching the ground, and it is technically a tornado when there's swirling dust underneath a condensation funnel, because the vortex is still touching the ground. And then lastly, we do want you to report funnel clouds as well. That's whenever we see a violently rotating column of air that's not touching the ground. So there's no evidence in the image on the lower right. There's no evidence of swirling dust at the ground, but that is a rotating column of air that's not in contact with the ground. And we definitely need to know whenever our spotters see something like that, because it can easily become a tornado within the next minute or two. So how to report? There are 4 ways we want you to report severe weather, all right? And please only choose one. So only choose one way to report severe weather. So the first and easiest way is to call our spotter line, and this is to talk directly to a meteorologist. Just call 888-745-1637, and you'll speak directly to a meteorologist and let them know where you're at and what you see. The second way to report severe weather is through our reporting website, and that is the URL at the bottom, NWS at nsep.noaa.gov/report. So here, the cool thing is you can use this on your mobile device, and you don't have to know exactly where you're at as long as your location is on, and it'll report the latitude and longitude to us, and that way we know exactly where you are and where you're reporting and what you're reporting as well. So that's kind of an easy way to do it, is to have this website bookmarked on your smartphone. A third way to let us know of severe weather in your area is our Facebook page. So if you go to facebook.com/NWS Flagstaff, and you can report severe weather that way as well. If you're not into Facebook and you're more a Twitter person, we have a Twitter page at NWS Flagstaff. You can also report directly to our meteorologists on Twitter. So again, there's 4 ways to contact us and report severe weather. Please only choose one of these ways. And with that, you are a certified storm spotter, and we have a link on the bottom of the video if you'd like to sign up to be a storm spotter in our database. And again, your personal information just sticks with the Weather Service, and you can email me at any time, tony.merriman@noaa.gov, and if you have any questions or if you want to be removed from our spotter database, that is the easiest way to get in contact with me, and I can remove you from the database or I can add you to the database, whichever one you prefer. So thank you so much for watching, and if you have any questions, feel free to shoot me an email, and you have a great day and a wonderful week.